Hello everyone, welcome to Start Tech. So in today's video we are going to discuss key features of Spark 3.0 which can be asked as an interview question as well. So let us begin. So regarding performance for Spark 3.0 or what are the new changes? So the new changes revolve around Spark performance and that are related to like adaptive query execution, dynamic partition pruning. It also supports Delta Lake, in which you can perform ACID transactions as well as in Spark 3.0 leverages use of Kubernetes. In Spark 2.0, there was Kubernetes as well, but now it has been more improved as compared to previous. So these are some of the key features you can mention in an interview like performance, asset transaction, Spark Kubernetes support, join hints. Okay, so let us discuss all these points in details. So as of now, in 3.0, Catalyst Optimizer, how it was working previously, it was rule based in Spark 1.0. In Spark 2.0, rule based and cost based Catalyst Optimizer was used. But now in 3.0, it gives a flexibility of choosing the right plan for your query to run like at a runtime. So runtime is in the Spark 3.0 it gives a much more flexibility and performance optimization in Spark 3.0. So what are all the features of AQE we will see. So what is AQE is adaptive query execution. So how it does is previously for Catalyst Optimizer, what Spark would do is it would create a logical plan. It would create a logical plan. It would create physical plan, and according to the cost which is lower, we would select a plan for executing the query, which is in the low level at a DAG level, RDD level, DAGs at the RDD level. Now, in adaptive query execution, what is done? So, in adaptive query execution, at the runtime, you can choose based on the statistics and you can re optimize the execution plan. How you can do this? You need to enable it. Uh, I would write the property name in the description box below. You can check that out and we'll see what are all the key features or key components of adaptive query execution. So for adaptive query execution there are three fundamentals which are done. So dynamically switching join strategy, dynamically coalescing shuffle partition, and dynamically optimizing skew joins. So we'll see each of them in detail. So first is coalescing the shuffle partition. So in a shuffle partition, it majorly depends how the partition are defined on the data. If you have a huge file, the number of partition will be more. Okay, and it depends on the data size and much more on the how the partition is done. So consider this as an example, and we have this many partitions. Okay, so we are having some of the partition as low, which is less. Okay, so what happens in AQE is now like you would have you can coalesce these partition into a single partition. Okay, so this is how coalescing shuffle partition comes into picture in AQE. So basically, what happens is in AQE now, previously this file was divided into these number of partitions. Okay, but now in AQE what happens is, wherever the small partitions are there, those are combined into a one huge partition. So this is the, this is the advantage which we are getting in AQE, which we were not getting in the previous version of Catalyst Optimizer. Okay, next is join strategy, optimizing or re-optimizing the join strategy. So Spark provides different kind of join strategies, right? So now for consider this example. So we have two tables, and from the uh, from the stats, we understand that sort merge join can be used by the previous version of Catalyst Optimizer. How? Because the size is more of the right side of the table. Due to that, the final execution join strategy was to use a sort merge join. But actually, it for the right side of the table, the actual size is 8 MB. That is, uh, I mean, we can do a broadcast join, correct? But in previous sections, at the runtime, selection was not done. So there can be different, different cases where it can go wrong, like due to this filtering, or selecting different join operation. This can go wrong. So in the now AQE, this is been improved, and at the runtime we can switch the join strategy. So this is how it does in AQE now, which is quite cool. And optimizing skew joins. So for this thing, in previous Catalyst Optimizer or in the previous version of Spark, we would have to write some of the logic for optimizing the skewness. We need to add some of the keys, and then have to repartition the for the skewness. So for example, here we are we are joining these two, and here we have a large partition. So for this particular partition to execute, it would take much more time than the other partition, because it is not it is skewed, and it is not properly arranged or shuffled, I mean divided into number of partitions, which is not proper. So but now in AQE, you need not write anything for this kind of skewness. It would be handled internally, and what it would do is it would divide this, the which is skewed, into this. So this kind of optimization done by AQE, here the developer needs to only write the business logic and concentrate on business logic and not on the skewness, which in the previous version developer need to decide, like if some job is failing or some job is taking much time, then developer needed to check why is it so. Is it because of the skewness? Then developer had to rewrite some of the logic for doing this. So this is quite cool and quite great feature by Spark in Spark 3.0. So in an interview, you should mention all these points, so that there would be a high chance that you are updated. The last feature for in the Spark 3.0 related to performance is dynamic partition pruning. So what is dynamic partition pruning is, previously also we had partition pruning, but in 3.0, Spark 3.0, what they have done is, suppose now we have consider a star schema, or data warehousing kind of concepts, like we are doing a join on these two tables for example, and one is the dimension table and one is the fact table. So dimension table would be a smaller table, and the fact table would be the larger table. So what happens in 3.0 is now, like, filtering logic was applied on the dimension tables, but now while you are doing a join, then at the at that time this filtering would also be done automatically for your fact table, for the larger table. So that would eventually improve the performance of the query, or your job, Spark job. So I hope you liked all the features which are mentioned for Spark 3.0. Do like and subscribe, and also please share your thoughts in the comment section below on which more topics you would like to have. We need more to cover. Thank you and bye bye.